final video in this series will be light affecting rates of reaction. Oh, well, actually, rates of reaction. Okay, so we're going to study about the effects of light on rates of reaction. So come on closer. So light, the main source of light, the main stuff in light that we're interested in is ultraviolet light, which is UV light. All right. Light is basically energy. It's some stuff, right, of energy stuff that are called photons. Photons. All right. When light hits on certain chemicals, it excites them. It makes it energetic. This excitation means that energy is absorbed. So, for example, I have here is the energy profile of a reaction, right? So you have the high activation energy over here. And so without light, the energy of the system is maybe about here. And when you put light into it, okay, and you excite this energy state from here to up here. So the total energy in the system is now up here. And so for chemical reactions to be successful, it's a lot easier for reactions to occur, all right? So this is why chemical reactions can happen. So now I'm going to talk about two examples, plus another one of my own, on how different of photochemical reactions. So the first example is pretty easy. It's photosynthesis. Plants. The stuff in plants called chlorophyll with light, allows the plants to convert CO2 and water to oxygen and glucose. We know this, right? Remember, photosynthesis is an endothermic reaction, which explains why you need light to induce, to overcome this high activation energy barrier, right? So it's an endothermic reaction. So you need light to change the energy from here to up here. Okay? And another example is an old school example in photography films. And so on films, there are silver halide particles, and silver halide is simply silver salts with either chlorine, bromine, or iodine attached to it. And for photography films, it's usually silver chloride. So they have silver salts, and when light hits on it, it will change into silver and those diatomic halogen particles. And in this sense, you have developed your film. And a more updated example that I'm going to use is called photochromic lenses. And transition lens is perhaps the most famous of this brand name class of photochromic lenses. I think that's on this H there. Okay, photochromic lenses. Okay, and these lenses are quite special because inside room, in a room, there's less UV light, and so the lenses are clear. And when you go outside under the sun, UV light will hit the lens, and then it will induce a chemical reaction to occur. And then what happens is that the lens turns dark, and so you block UV light as well as sunlight, visible light. And so the chemistry of photochromic lens reactions are pretty complicated, and there's a lot of proprietary things that is not easily accessible. But basically, it's organic molecules in one form, and then when UV light hits on it, it changes shape, right? And or breaks up and change its shape. I don't want to use complicated words, change shape. So, okay. And so that change of shape creates this sunglass effect. All right. And when you go back into a room, the chemicals will revert back to its original position. So there you go. Examples of how light can help in terms of chemical reactions.